Hello, my name is Facundo Molina and I am a postdoctoral researcher at IMDEA Software Institute, and in this demo I'm going to present SpecFuzzer, a tool for inferring class specifications via grammar-based fuzzing. So in object-oriented design, where software is organized as a set of classes equipped with methods, a class specification describes the constraints that the class object needs to satisfy and the intended behavior of its methods. Mostly, class specifications appears in implementations informally, through natural language documentation of its API. For example, for this list implementation, they express properties such as the size field must be equal to the actual amount of elements, that the add method actually inserts the elements in the list, and so on. However, class specifications become significantly more useful when expressed formally through executable constraints known as contracts. For instance, these contracts can involve class invariants, such as the fact that for any list object its size must be equal to the actual number of elements, preconditions, as the one stating that the input to the add method must be different from null, or postconditions, such as the one stating that the input to add was actually inserted in the list. The relevance of automatically generating class specifications can be seen in many situations. For instance, in the context of regression testing, as implementations evolve with time, one may be interested in checking whether the original behavior is preserved. In differential testing, given different implementations of the same class specification can be used to analyze if this implementation behaved the same. In the context of program comprehension, they can be used to inspect what does the class under analysis do. Moreover, Daikon, a well-known tool for inferring specifications, has enabled a number of applications, including program repair and fault localization. In this tool demo, we present SpecFuzzer, our tool for automatically inferring class specifications. SpecFuzzer is a command-line tool that, given a Java class and a test suite for it, produces a set of assertions that are likely to hold in specific program points of the class, including class invariants, preconditions, and postconditions. The approach uses a combination of grammar-based fuzzing to produce candidate assertions, dynamic invariant detection to determine those that are likely to hold, and mutation analysis to discard irrelevant redundant ones and report the more relevant. SpecFuzzer uses fuzzing to efficiently produce many candidate class specifications and incorporates mutation analysis to eliminate redundancy and to improve precision. Given a target Java class and a test class for it, possibly generated with a test generation tool such as Rundup, the SpecFuzzer workflow is organized in the following pipeline. First, it uses an assertion fuzzer to generate thousands of candidate assertions. Second, the candidates are passed through Daikon, the dynamic invariant detector, to determine the ones that are likely invariants. And finally, an assertion selector takes the valid assertion and produces the most relevant subset of assertions relying on mutation analysis. To illustrate the usage of SpecFuzzer, let's consider the following implementation of ordered lists of integers featuring a method to insert an element in the list and a method to clear the list. Also, let's assume that we have the following test suite executing the methods of the sorted list class. To generate a class specification with SpecFuzzer, we need to perform two steps: the setup step and the inference step. Once SpecFuzzer is installed, the setup step is performed by running the SpecFuzzer script with the option --setup, which receives the target class path, the target class name and source file, and the target test suite. For example, within our artifact, by running the following command, it will first generate the grammar and then will start performing the mutant generation with major and collecting the test suite execution traces. This process produces the main files for the next step: a grammar extracted from the target class, a dtrace file summarizing the execution of the test suite, and a set of mutants generated with Major. Then, the inference step is performed with SpecFuzzer, a script with the option --infer, which again receives the class path, the target class name, the target test suite, and also a method name to focus the analysis on. Then, in our tool, if we run the mentioned script, it will first fuzz a lot of candidate assertions that will be fed to Daikon in order to infer the class specifications for our target class. At the end, SpecFuzzer will report the output separating those specifications that hold as class invariants and those specifications that holds as method postconditions. And finally, the SpecFuzzer output will be saved in a .assertions file. To give an insight into the specifications that SpecFuzzer can infer, for the sorted list class, the output contained the following properties. As invariant properties, the facts that the list is sorted and that the sentinel is always present in the list were captured. For the method insert, the property stating that the method data was actually inserted is also inferred, among other properties. To conclude, SpecFuzzer is a class specifications inference tool for Java. It uses grammar-based fuzzing to efficiently produce candidate specifications, support rich contracts including navigation and quantification expressions, and finally it is publicly available on GitHub, where you can also find examples and further documentation. Thank you very much for listening.